Today we're going to be looking at how to display quantitative data using dot plots. So the goals of the lesson today is to be able to make and interpret dot plots of quantitative data and describing the shape of distributions as well as comparing these distributions for quantitative data with the use of the dot plot skill. So the vocab includes the definition of the dot plot, symmetric and skewed distributions, and the type of skewed distributions, such as positively skewed or negatively skewed. All right, so from the last lesson, we talked about bar charts or pie charts, and these are used to display categorical data. If you recall, categorical data data that is based off of labels and can be numerical as long as they're labels such as zip codes, or more specific wording labels such as blood type, etc. A dot plot, however, is going to be the simplest graph for displaying quantitative data, which is data that is numerical that makes sense to be averaged. So a dot plot shows each data value as a dot above its location on a number line. So for example, if we're reporting the number of siblings by each student in a statistics class, let's say that our range is from 0 to 7 students, or siblings rather, and we ask the students how many siblings they have. So for example, it seems that 4 students have 0 siblings, and it seems that 4 students also have 3 siblings. So that's how you interpret the dot plot. So how do we make one? Well, it's pretty simple. You're just going to draw and label the axes first. You're going to draw the horizontal axis and put the name of the quantitative variable underneath. So in our previous example, it was the number of siblings. You're going to scale the axes, find the smallest and largest values in the data set, and then start at a number equal to or less than the minimum value, and then make equal intervals until you exceed or equal the maximum value. Then you want to plot the values by marking a dot above the location for each data value and stack the dots for frequencies greater than 1. Make sure that you make all the dots the same size and space them out equally as you start stacking them in the graph. All right, so the Environmental Protection Agency is in charge of determining and reporting fuel economy ratings for cars. Here are the EPA estimates of highway gas mileage in miles per gallon for a sample of 21 model year 2014 mid-size cars. So the first part wants you to make a dot plot of the data, and the second part wants you to explain what the dot above 38 represents and what percent of the car models get more than 35 mpg on the highway. So on the right is a table of the 2014 mid-size cars with various mpgs. So putting that graph back up here so that we can reference it, we're going to start making and drawing and labeling our axes. So notice that I labeled the highway gas mileage. So that's our quantitative variable. The next step is to scale. So we're going to start with we know that the smallest value is 25 mpg and the largest is 48. So it kind of makes sense to start at 25 and at 50 and then just go by fives. So that's what I did here on the axes. The next step is to plot the values. So notice that there are two 25s here, so I'm going to stack 2 dots there. There's 126, so I'm going to stack 1 dot there. There's 127, 2 28s, 5 30s, 5 31s, 132, 134, and so on. So I got 138, 140, and then I have one that is greater than 45, so about 48. So there's my dot plot. So now for part B, we want to be able to interpret the dot above 38. So the dot above 38 represents the 2014 Hyundai Elantra, which gets 38 miles per gallon on the highway. So that's actually the model car that I have. Not that year, but the model Elantra, interestingly enough. So for part C, it says It's asking, what is the percent of those that get more than 35 mpg on the highway. So notice that if you look at the dot plot, there's 3 cars that have a mileage that is greater than 35. And there are 21 cars in total, 21 dots in total. So we take the 3 divided by the total of 21 and then times it by 100 to get into a percent. Turns out 14.3% get more than 35 miles per gallon. All right, so the next thing we're going to talk about is how to describe the shape of a distribution, which is kind of important to be able to look at it visually. So when describing the shape of graphs, focus on the main features. So for example, major peaks, not for minor peaks and dips on the graph. Since no graph is going to be perfect, you want to generally look for the major features that define the graph. You want to look for obvious clusters of values and gaps, and use the graph visual to decide if it's roughly symmetric or skewed. So these are the types of shapes that we're going to be looking at. So for a symmetric distribution, it's roughly symmetric if the right side of the graph is about the same as it is on the left side. So basically they're mirror images of each other on each half. As opposed to a skewed distribution is not symmetric by any means. If you're talking about a skewed to the right distribution or positively skewed, then this means that the right side of the graph is longer than the left side. So for example here, if you divide it on the right side, the tail on the right side is longer than the tail on the left side. Distribution is skewed to the left or negatively skewed if the left side is longer than the right side, such as the graph below. And note that the direction of skewness is towards the longer tail, not where the data is clustered. So if I'm saying skewed left, I'm really saying that the left tail is longer. It's not where the peak is or where the mountain is. It's actually where the tails are. All right, so the dot plots below display 2 different sets of quantitative data. The first graph shows the EPA gas mileage data from the previous example, and then the second graph shows the results of 100 rolls of a die. A fair die from with numbers 1 through 6. So describe the shape of each distribution. So for the highway gas mileage, the dot, if you look at it, their peak is around 30 to 31. So, and notice that the right tail on the right side is longer, it's more spread out than it is on the left side. So therefore the dot plot is skewed to the right or positively skewed. The main cluster is between 25 and 34, and then the rest of it is kind of spread out on the right side. For the 100 rolls, notice that it's equally spaced and all the heights are about the same, roughly speaking, and it looks symmetric. So if you were to cut it in half, it's about the same on each side, roughly speaking. There doesn't seem to be a clear peak, so this actually has a special name. When the heights are roughly the same with the where there's no clear peak, the distribution is called uniform. So as we can see, some distributions have easily described shapes. However, in the real world, many distributions have irregular shapes that are neither symmetric nor skewed, and they're not so clear cut. In this example, you can see that there's 2 clusters of data. So this is the data for 220 eruptions of the Old Faithful geyser. This is the duration of those eruptions. So as you can see, there's a couple of clusters around the 2 mark, and then around the 4.5 minute mark. So there's clearly 2 main clusters and 2 clear peaks, and this is called bimodal. So if you have 2 peaks, we call it bimodal because the mode is the most popular number. So it seems to be that that there's 2 really popular durations in this example. So we call it 2 modes or bimodal. If it only has the single peak, it's called unimodal. So now we're going to describe and compare these distributions to each other. So what do we look for when we describe the distribution? Well, in any graph, you want to, again, look for the overall pattern and for clear departures from that pattern. Okay, the key is the overall pattern. So if you want to describe the overall pattern, you need to use characteristics such as shape, center, and variability. So the shape is basically what we mentioned earlier, whether it's symmetric or asymmetric. And if it's asymmetric, is it skewed left or skewed right? Or if it's uniform, etc. Or unimodal or bimodal. So those are things that kind of describe the shape. For the center, you want to look for the clusters, and you want to look for the middle of the clusters. So the middle of cluster is sort of like the average. And the variability is how spread out the data is. So variable, vary means to change. So you want to see how much the graph changes and how much it spreads out. So an important type of departure is the outlier, which is what we call an extreme value. So it's a value that falls outside the normal pattern. So it could be an extremely small number or an extremely large number. And we'll see an example of that. All right, so how do the numbers of people living in households in the United Kingdom and South Africa compare? To help answer the question, we use Census at School's random data selector to choose 50 students from each country. Here are parallel dot plots of the household sizes reported by the survey respondents. So compare the distributions of household size for these two countries. Right, so we want to compare the shape. So if you compare the shape of the South Africa distribution to the UK distribution, it seems that the South Africa distribution has a right side to it, and it has a longer right side. So it has a longer right tail. So therefore it's positively skewed or right skewed. And that's because of those extreme numbers that you see on the right side at 15 and around the 26, 27 mark. It also has one peak, one clear defined peak, so we'll call it unimodal. The UK distribution is roughly symmetric on both sides. If you were to cut it in half, is roughly, and has the one peak, so it's unimodal. Now, as far as the center goes, if you look at the cluster for South Africa, it seems to be around 6. If you look for the cluster for UK, the center is around maybe 4 or 5. So therefore, it seems to be that the South African students have a greater measure of center than that of the UK. Household size. So on average, it seems to be greater. If you look at the variability or the spread in the data, it's clear that the South Africa distribution is more spread out than the UK distribution because of those extreme values on the right side, the 15 and the 26. It goes from 3 to 26 for the South Africa graph, so therefore it's pretty extreme as far as the spread. Whereas if you look at the UK, it only starts from 2 people and ends at 6 people, so it's not very spread out. If you look at the outliers, again, the reason why the South African distribution kind of seemed to be skewed right is because of those is partly because of those outliers at 15 and 26. For the UK, it's symmetric. There doesn't seem to be any outliers. All right, go ahead and try the following problem. Pause and try the video first. All right, so let's go try the following problem. So the data below represents nitrate concentrations. So nitrates are organic compounds that are our main ingredient in fertilizers. So when the fertilizers run off into streams, these nitrates can be dropped off into the stream and have a toxic effect on fish. So an ecologist studying nitrate population in 2 streams measures nitrate concentrations at 42 locations on Stony Brook and 42 locations in Millbrook. The parallel dot plots display the data. So we want to explain what the dot above 12 in the Stony Brook graph represents. So I went ahead and put in the graph on this next slide. So we want to be able to explain the dot above 12. So there's one location in the Stony Brook stream, notice, that recorded a concentration of 12. So that's what the dot above 12 represents, is that we got that reading. What percent of the nitrate concentration measurements exceeded 10 milligrams per liter? So if you look at the Stony Brook, there are 42 locations on Stony Brook in total, but only 2 exceeded the 10. So if we wanted to calculate the percentage, we just simply have to take the 2 divided by 42 and then times it by 100 to convert it to a percent. So we got about 4.76%. So now we want to compare the centers of the 2 distributions. So if you look at for Millbrook, the concentration, the center of Millbrook seems to be around 9 to 10, so the center of that cluster. If you look at the Stony Brook, the center is around 4, around the 4 mark milligrams per liter. So it seems to be that the center for Millbrook is greater than that for Stony Brook. So on average, the Millbrook concentrations are not looking very good. So what about the variability? Well, if you look at the variability of Millbrook, Millbrook is more spread out than that of Stony Brook. So the Millbrook varies from 0 to 20 milligrams, whereas the Stony Brook only varies from 0 to the 12 milligrams per liter. There also seems to be a couple outliers for Millbrook, which contributes to its vast spread at 18 and 20. All right, so to summarize the lesson and what we've done, we discussed dot plots, and we discussed that they're used for quantitative data only, as opposed to bar graphs and pie graphs, which use categorical data. The dot plot is the simplest type of graph for using quantitative data and uses dots to uses stacked dots to represent frequencies of data values. We also discussed how to make and interpret these dot plots. We kind of discussed, the shapes of distribution, such as whether it's symmetric or skewed to the right or left. And then we were describing and comparing distributions that involve these dot plots. We discussed that some things that you can describe are the shape, center, variability, and the outliers. Again, the shape being those shapes, symmetric or skewed, center being like around the average, variability, the spread, and outliers, extreme values. All right, next up, we're going to be going over, in the next lesson, we're going to be looking at quantitative data again, but with the use of stem plots.